In this video, I'm going to discuss multiplication and exponentiation with integers. So you may recall that when we have multiplication with natural numbers, we can interpret that as repeated addition. All right, and you may also remember that it turns out that the order doesn't matter. You can add 3 4s together or 4 3s, and you'll see that they both give the same answer. The word we used for that was commutativity. So multiplication is commutative. But this time we're going to talk about integer multiplication and how is it different. So if both integers are positive, clearly it's just the same old stuff we learned before for natural numbers. What is new is if the numbers are negative. Okay, and I'm going to have you memorize the following pattern. If you multiply integers, if one of the numbers is negative, and it doesn't matter which one, as long as just one, it's the quantity I'm looking at. If the quantity of negatives is odd, if it's, in this case, there's one negative for each one, then the answer is going to be odd. Okay? Now, if, on the other hand, you have two negatives, if the quantity is even, if you had more than two numbers multiplied, then the answer is positive. All right? Now, the original problem, 3 times 4, had no negatives. Okay? Well, 0 is even, so that's why we can say that this one's positive with our pattern. All right, so one negative makes, or one negation, whatever you want to call it, makes the answer negative. Two negatives makes the answer positive. You might also think of it as the two negatives kill each other, blow each other up, whatever you want to think. All right, now let's see if integer multiplication is commutative. All right, so 3 times minus 4 it's minus 12, and minus 4 times 3 is also minus 12. So at least for this example, it looks like it's commutative, and it turns out it'll be true for all products of integers, because which one you make negative doesn't matter, and the order, at least for natural numbers, we know that it doesn't matter for that, but now you'll discover that it also doesn't matter for integers. Okay, so it's commutative. It's also associative. So if you did minus 2 times 3 times minus 4, and let's do it let's do it two different ways. So one way that we could multiply is we could do the first pair, find that product, and multiply that by minus 4. Or we could do the second pair, the second product, multiply that by minus 2. Either way, you will get the same answer. So the first will give minus 6 times minus 4, which is positive 24. The second way will give minus 2 times minus 12, which is positive 24. Okay, so we say that, again, multiplication with integers is commutative and associative. All right. Now, sometimes it will help to think of a negation as an integer multiplication. This is just a side note. File this in the back of your mind. It might be useful in the future. But if you have minus something, the negation of a number, that is the same as if you took the number and multiplied it by minus 1. All right, so that's minus 4, right? Because we have one negative in the product. Now, one way that that might be useful is understanding when you have two negations. So what if I had like minus 6? Okay, well, we can interpret that as, again, the point I'm trying to make is you can interpret negations as multiplying by minus 1. So we can interpret this as minus 1 times minus 1 times 6, all right? and we know it's associative, so let's multiply the minus ones together first, and that's going to give us a positive 1 because we have an even number of negatives. So this is 1 times 6, 6. Okay, so maybe that might be useful to you. And then let me close this video by talking about something called the distributive property that may also be useful. Actually, before I do that, let me remind you that exponentiation is just repeated multiplication. Okay, so you can use that to understand exponentiation with integers. All right, so for example, suppose I had minus 1 cubed. All right, well, first write out what it is in terms of products. And now you can just use what I've been talking about in this video. So let's see, we've got 3 negatives. That's an odd number of negatives, so the answer is going to be negative. Then you ignore the signs for a minute and just multiply the 1 times 1 times 1, so you get 1. See that? So if you understand multiplication with integers, you also understand exponentiation with integers, is what I'm trying to say. All right? Okay, so now the last point I wanted to make was the distributive property. If you have something like a number in front times a parenthesis like this, you can either add the 3 plus 4, and that would give 2 times 7 to 14, or I want to make you aware of this other choice. You could do these two products, 2 times the 3 and add that to 2 times the 4. So 6 plus 8 will also give you the same answer. That's called distributing. Now, let me show you that with an example that it's also true with integers, with negative integers. All right, so let's go ahead and do that. So this second way to solve this type of problem works with negative numbers as well. So if you had minus 4 times, let's do a really hairy one, times minus 1 minus 3. All right, so first we'll do it the standard way, where you just first combine you simplify the parentheses, so that's minus 1 times minus 4, but we already know what a negative times a negative is. That gives 16. And then by distributing, now you're going to get to use your multiplication skills. Minus 4 times minus 1 is the first product, and for the second product you can either do you can add minus 4 times minus 3, or you can subtract minus 4 times 3. So I will do let's see, I will do plus minus 4 times minus 3. Okay, now what I was saying in words was that you also could do minus 4 times minus 1, and then do minus 4 times minus 3. Okay, whether you add a minus, I'll work both of those out, and you'll see that they're the same, and we quit talking. So the first one is 4 plus 12, which gives 16. The second one is 4 minus negative 12, which also gives 16. All right?